Class 2, Quantum Bits, Qubits, and Superposition. Recap from Class 1. In the last class, we learned that classical computers use bits 0 or 1. Quantum computers use qubits 0, 1, or both at once due to superposition. Entanglement allows qubits to be connected in a way that classical bits cannot. 1. What exactly is a qubit? A qubit is the basic unit of quantum information. A classical bit is like a switch, either ON, 1, or OFF, 0. A qubit can be 0, 1, or any combination of both at the same time. This is called superposition. Mathematical representation. A qubit state is represented as \psi wrangle equals \alpha 0 wrangle plus \beta 1 wrangle. Equals state of the qubit. And equals complex numbers, probability amplitudes. And equals basis states, like classical 0 and 1. The total probability must equal 1. Example, if and the qubit is in an equal superposition of 0 and 1. When measured, there's a 50% chance of getting 0 and a 50% chance of getting 1. 2. Superposition explained. Superposition means that a qubit can exist in multiple states at the same time until measured. Example, a classical bit is like a coin sitting on a table, it's either heads, 0, or tails, 1. A qubit is like a spinning coin, it's both heads and tails at the same time until it stops measurement. Why it's useful. 1. A single classical bit can store one piece of information, 0 or 1. 2. A single qubit can store two pieces of information, 0 and 1, simultaneously. 3. More qubits, more information stored and processed at once. Example, 3 classical bits equals 8 possible combinations, you can only store one combination at a time. 3 qubits equals 8 possible combinations, you can store all 8 combinations at once due to superposition. 3. Measurement and collapse. When you measure a qubit, the superposition collapses to either 0 or 1. After measurement, the qubit behaves like a classical bit, 0 or 1. Example, 1, a qubit in state. 2. Measuring it, there's a 50% chance of getting 0 or 1. 3. Once measured, the qubit collapses into that state permanently. 4. Block sphere visualizing a qubit. Qubits are represented on a block sphere. The north pole equals. The south pole equals. Any point on the sphere represents a possible state of the qubit. Superposition equals a qubit is located somewhere between the north and south poles. Classical bits sit at the poles, 0 or 1. Qubits sit anywhere on the sphere, representing infinite possible combinations. 5. Why superposition is powerful. A classical computer with 3 bits equals can only hold one of 8 possible states at a time. A quantum computer with 3 qubits equals can hold all 8 states at once due to superposition. Homework, a thinking exercise. 1. What is the difference between a classical bit and a qubit in terms of superposition? 2. If you have 4 qubits, how many states can they represent at once? 3. Why does a qubit collapse when measured?